all of the values, we will get 0. If we give 0 here, we will get 0. If we give here 0 and here 1, again you will get 0 and 1, 0 and 1, you will get 0 here. As we have already learned AND gate, now we will move to OR gate. So in case of OR gate, we will give suppose we are using 2 input, then we will give a 2 pin in the left side and 1 pin on the right side for getting output, that is Y here. So we will draw the logical diagram by following some easiest method. Just like AND gate, we have followed the uppercase D, and here we will also follow the uppercase D, the rule, but we will curve though that uppercase D or the capital letter D. And while we want to remember the truth table, we will follow a easiest technique, that is if any of the block or any of the box has one value or true values, then we can or we are allowed to share 1 in the output section. As you are visualizing, here we have got 1, that's why we gave 1 here. Here we got 1, here we also gave 1 here. So otherwise you are you will be giving 0. And in case of symbol, AND gate, we in case of AND gate, we were using A dot B or A concat sign B. And in case of OR gate, we will be using A plus B. Here plus is the we are indicating that is it's the OR sign, or it's the OR gate, A plus B. Then we move to NOT gate. NOT gate, we will remember this logical diagram as the arrow sign. We will give arrow sign, after that we will give a dot or a unmarked circle, that is see, first of all we just gave arrow sign. After that you can give unmarked circle. Okay, unmarked circle, there will be unmarked circle. So this will be the NOT gate. So what does this mean? This means that if someone gives you 1, the output will be 0. If someone gives you 0, the output will be 1. You can remember is just like some toxic people. What does they do? They say something and the meaning will be a different thing. So just like that you can remember this NOT gate. Okay, and for remembering AND gate, you can use some techniques such as if someone is in a relationship. Okay, if someone is in a relationship, the boy should involve, or boy should be committed to the girl and the girl should be committed to the boy, and then that the relation will long last, or the relation will go to a further direction. So that is the AND gate. And what is OR gate? OR gate is whatever the situation is, the boy may love, the girl may not, the girl may love, the boy may not. Whatever the situation is, anyone, if a love that is present, then that is the OR gate. That is you are giving 1, any side you are getting 1, you are giving 1 in the output section. After that we move to universal logic gate. How many types of universal logic gates were there? There were 2 types of universal logic gates, that is NAND gate and NOR gate. NAND gate is just opposite to AND gate, that's why it's NAND gate. What does that mean? That means that if we give NAND, what does that means? This means that it's AND plus NOT, NOT plus AND, NOT plus AND. Okay, so at first of all, we can draw the, or we can yes, we can draw, or we can just draw a table. That is first of all A, B is the input. So let's share the input 0 0 0 1 1 0 1 1, done. And we will write AB. AB is for AND gate. What it is for? AND gate. Okay, so we know that is the boy and the girl is falling into a deep relationships. Okay, so that's why where there will be 1, there will be 1 in the last block or last section. That is both side we are getting true answer, so that's why we are giving true in the output section. Besides or otherwise we are giving 0 here. Done. And what will be in case of NAND gate? That is NAND gate. So NAND gate will be nothing but the opposite of AB or AND gate. NAND gate. Okay. So what will be the answer? 0 will turn into 1, 0 will turn into 1, 0 will turn into 1, and the 1 will be turned into 0. So that is the NAND gate. Done. So after that we will move to OR gate, then NOR gate. Okay. First of all we will write A plus B. What it is for? It is for OR gate. Okay. So it is for OR gate. So we know that OR gate is anyone can love. Okay, just love will be present. The boy can love the girl can love the boy, but love is present. Okay, so we will give 1 here, or the true value here. So 0 1 gives us 1, 1 0 gives us 1, 1 1 gives us 1, and otherwise 0. Done. And after that, in case of A plus B, that is bar, sign bar, then it is a NOR gate. So in case of NOR gate, what we will give? We will give the opposite of OR gate, that is not plus OR. Not plus OR is equals to NOR gate. Okay. So 0 will turn into 1, 1 will turn into 0 1 0 1 0. Done. So let's check with our book or the slide. So NAND gate done. Yes, NAND gate 1 1 0. So what we have? 1 1 1 0. Yes, done. After that we have universal logic gate, that is NOR gate. Truth table done. Truth table, yes, it's matched, so it's done. So how we will we are already done with our truth table. So the question will be, then how can we remember the logical diagram? It's a look complex, so how you can remember? So it's also easy. So just see, in case of NAND gate, as we already have shown, or we already have seen, that is this is the AND gate, this is the AND gate. And what will be the NAND gate? NAND gate is nothing but unmarked or uncircled dot or circle beside the AND gate. So this is the NAND gate. And what is the NOR gate? NOR gate is nothing but there will be an unmarked circle in front of OR gate. So see, this diagram you will remember for your exam or some interview. Okay, so after that we will move to we can use this and NAND gate or NOR gate, and we can make them available, or we can use them as AND gate, NAND gate, AND gate, OR gate, or NOT gate. So how we can use? So see, we have written in this slide, that is one NAND gate is equivalent to NOT gate. One NAND gate will gives us or share the value, or we can act them, or we can use them as NOT gate. So how we can use? Just see. At first of all, how we can use. Okay, so at first of all, let's draw the NAND gate. Let's draw first of all the NAND gate. So it's the NAND gate. Okay, so it's the NAND gate. So we know that in case of NOT gate, we have only one input. We have only one input. So we have only one input, that is 1. So in this 1, the 1 will move and it will go as 1 and 1. It's you are giving 1, but it will go in a similar direction, or it is go in a same direction or same path or same gateway. So that's why the value will be same, that is 1 1. So in case of AND gate, just think of this AND gate part, AND gate. So in case of AND gate, what you will have when you are giving 1 and 1 here, you will have 1 1 and the answer will be output as a 1. Why? We already have remembered by the boy and girl rule 1. So after that you will see that it's the unmarked circle here. An unmarked circle, what does that mean? That means you will have 0 here. That is, if there is 1 here, the answer will be 0. If there is 0 here, the answer will be 1. Just vice versa. Okay, so there will be 0. So it's acting like a, say, it's acting like a NOT gate. So one NAND gate is equivalent to one NOT gate. This is the way they're working. Okay. After that we have, and moreover you will remember that it's called as, or it's termed as, or it's coined as inverter. This is very important. Okay. After that we have NAND gate as AND gate. So in case of using AND gate, or if you want to get AND gate from NAND gate, you need to use two NAND gates. So what does that mean? That means that, let's see, what does that mean? That means that if we are following the diagram, so how these are working as AND gate. Okay, so first of all we are giving, suppose we are giving 1 and 0. Okay, you are giving 1 and 0, and what does the how is the truth table of AND gate? The truth table of AND gate is, if we get in all the block true values, then we are allowed to give out as true values in the output. Like if you are giving A, B, C, there is 3 input, so you are giving 1 1 1, then the output will be 1. And if the values is 1 0 1, that is you are getting here 0. But we have already said that in all the block or in all the boxes you must have 1, or you must have true values, then only you are allowed to give 1 here. That is this. Okay, so we are moving into our diagram, or the logical diagram. So see, so you are giving as input 1 and 0. Just consider this. This is what? This is AND gate. And in this AND gate section, you are having what? You are having 0 here. Why? 1 0 gives us 0 in AND gate. In case of this, what is this? This is nothing but a sign or some symbol of NOT gate. So 0 will turn into 1. So now as the value is going, or the path is going, or the road is going in 2 directions, but the road comes here as 1. So that's why 1 will move to there, 1 will move to there. So that's why 1 and 1 here is also AND gate. So that's why you are getting 1 here. After that you are considering it as NOT gate. So NOT gate 1, there were present 1. So now it will turn into 0. So see, you are giving 1 and 0 and you are getting 0 here. So what does that mean? That means in case of AND gate, you are giving 1 and 0 here and you are getting 0 here. So that's why you are saying that true to if we were using, or if we are using two AND gate, we are having, or we are using them as one AND gate. Two NAND gate are being used as one AND gate. Done. Okay, after that we will learn about OR gate. We can use NAND gate as OR gate. How we can use? See, we will also learn in our easiest method, just like the previous one. So see, so first of all, and what we are doing, we are just tracing the values what they were saying we are getting on. So let's see. So if we are giving one here, and let's see one here, so one will be moved to here, one will be moved to here, one will move to here, one to move to here. So then after that, this is a AND gate, and this is also AND gate. Okay, so 1 gives us 1, 1 gives us 1. Okay, so here the 1 will turn into, it's a unmarked circle here, so it's turned into 0. It will turn into also 0. So 0 and 0, AND gate is present, so it will give us 0. Now or NOT gate is present. This is unmarked circle, so that's why it will gives us 1. So see, you are giving 1 here, you are giving 1 in another input, and you are getting 1 as output. What does that mean? That means it's acting like a OR gate. So 3 NAND gate, if you use them, you will get, or you can use them as one OR gate, and the two NAND gate is connected in a parallel direction and joined in a series. But in case of two NAND gate, while you are using them as AND gate, you are using them, or you are putting them in the arrangement of series connection. After that, we will move into another slide, that is NOR gate. So you can use the similar way, that is a NOR gate. You can use them as inverter, that is NOT gate. The two NOR gate, NOR. Remember, I am saying NOR, NOR. Okay, not NOR, NAND. So two NOR gate, you can use them as one OR gate, and three NOR gate, you can use them as one AND gate. Okay, after that we have two types of special type of gate, that is XOR gate and XNOR gate. So for remembering it, you can use the circle. You are while using OR gate, or while using the sign of OR gate, you are giving plus sign, and now you will give us round circle beside or around the plus sign. And for remembering the truth table, you will remember it as when you will have the same value. When you will have the same value, then you will give 0. That is 0 0 0, 1 1 0, whatever may it be. But when you are having, or you are visualizing, the input sign is similar or same, then you will give 0. Beside or otherwise, then will give 1. And for XNOR is nothing but the vice versa, or the opposite of XOR. So in case of XOR gate, what you are doing, you are just putting 0 when the mark or when the sign is same in all of the inputs. And in case of XNOR, just the vice versa, that is, while you are getting the same input, you are giving 1, that is 0 0 1, and 1 1 1, that is for XNOR. And the logical diagram, it will be like nothing but Suppose you are drawing XOR. What it is? It is XOR. So now you will give here a one type of bracket, the ending bracket you can. So as it is a type of we are drawing the XOR. In case of XOR, you will give normal, like it will be like this. And in case of XNOR, as n is present or not is present, so you will give an unmarked circle here. Done. Okay. After that you will have Boolean algebra at glance, like what we have already done, that is AND gate, NOT gate and OR gate. So their truth tables are present here. After that we have DeMorgan's law. So there is a French mathematician whose name was DeMorgan. He formulated two types of theorems in 1953, and they are known as DeMorgan's theorem. So they are present as or they are available as 2 variables format and 3 variables format. What does that mean? That means that in case of 2 variables, we have 2 as input, that is AB. We have 2 inputs, so that's why they have named as 2 variables. And in case of 3 variables, what does that mean? That means we have 3 inputs here, or we can give 3 input for our calculation. Okay, so if we are let's solve it. We will move to the solve part. So let's solve. So see how we can solve this DeMorgan's theorem. So while doing this, at first of all, what does that mean? That means that we have two variables or 2 inputs. So we are we are writing AB. So we have 0 0 0 1 1 0 and 1 1. Done. After that, what we'll have 1 bar B bar. That means A naught and B naught. A bar B bar. Okay. So 0 will turn into what? 0 will turn into 1. 0 will turn into 1. 1 into turn into 0. 1 into turn into 0. Okay. After that, B, there is present 0. We will give or we will write 1. For 1, 0. For 0, 1. For 1, 0. Done. After that, A bar dot B bar. Okay. So what does that mean? That means that we are using AND truth table. So in case of AND truth table, all the block or all the boxes must be tick marked. Then we are allowed to give a tick mark or give a true values to our output. So here we were having 1 1 as we are having 1. Then otherwise 0. Done. After that, A plus B bar. But we don't have A plus B. So let's first write or draw A plus B. So A plus B, that means OR gate. That means what? OR gate. So in case of OR gate, in any section or in any of the input, if we are having 1, then we are allowed to give 1 here. So A plus B, there will be 1 0 1 1 1 0 1 and 1 1 1, and otherwise 0. After that, A plus B bar, that is what? OR gate. And what is it? What it is? It's named as NOR gate. Just the vice versa of OR gate. So here we'll be giving 0 1 1 0 1 1 sorry 1 0 1 0 and 1 0. So see, this truth table section and this truth table section similar or same. So that's why they are equal. First case done or completed. After that, what we will do, we will move to another part. We have 2 parts. See, first section done, second part. So second part we need to prove this thing. Okay, let's prove this section. We can draw in this table also. We no need to move to a new table. If the teacher or if the examiner says or tells you to draw another table, or he or she wants to draw you another table, then you are allowed to do. Okay, so we are using our table which are already done for us. So we are using a dot b. At first of all, a dot b. So does we have a plus b? No, we don't have a plus b. So what will be the answer? A plus a dot b, that is AND gate. AND gate, we will have 1 1. So here we will have 1 0 0 0. After that, a plus b bar, a plus b, sorry, a dot b bar. So 0 will turn into 1, 0 will turn into 1, 0 will turn into 1, 1 will turn into overturn into 0. Done. A plus b bar. So a plus b, not fully bar, it's a bar plus b bar. It's different, quite different, huge different, right? So a bar plus b bar. So what does that mean? That means these two column section will be used as calculation for our next new column. So that means plus as its OR gate. So any of the section we have 1 1 1, we are allowed to give 1 in as output. So 1 1 1. So first three column will be 1 1 1 and last will be 0. So see, this section and this section is quite similar. So what does that mean? That means that we have already proved the black part marked as the first section proof, and the second where we are using red colored block or red color box, these are used as to prove the second part or second case. So we already proven DeMorgan's theorem with the help of our truth table. What does that mean? That we are using truth table. So you need to use, or you need to have in your mind the truth table, or you need to have the basic knowledge of the truth table while proving these DeMorgan's theorem. And in case of three variables, you can take it as a homework. You can solve it as a homework, and you can email me. Then after I can check, or I can say that how it can be done, or I can if you are not getting it, then I will show you more examples about three variables or something more.